Good morning, students. Let us continue with chapter 9, that is Force and Laws of Motion. In the last chapter, we studied what is force, the balanced force and unbalanced forces. In today's session, we will learn Galileo's concept of motion, Newton's first law of motion, along with some activities, the concept of inertia, and at the end we will do some sample questions. According to Galileo, objects move on an inclined plane with a constant speed when no force acts on them. As seen in picture A, the velocity of the marble that rolls down an inclined plane increases, whereas the velocity of the same marble when it climbs up an inclined plane, as seen in picture B, decreases. Students, here you might wonder, if speed is supposed to be constant as per Galileo's concept, then why does the velocity increase or decrease in reality on the inclined plane? What must be the reason for this? This is due to the unbalanced gravitational force of the earth. The picture shows a double inclined plane. According to Galileo, when the marble is released from left, it would roll down the slope and go up on the opposite side to the same height from which it was released. Before we study the three cases in the picture, students, please note the term inclination means the angle made by the plane of rolling down or the plane of climbing up with the horizontal axis. Now, case 1 shows that if the inclinations of the planes on both sides are equal, then the marble will climb the same distance that it covered while rolling down. But if, as in cases 2 and 3, the angle of inclination of the right side plane were slowly decreased, then the marble would travel further distances till it reaches the original height. In the last one, that is case 4, if the right side plane were made horizontal, that is, the slope is reduced to 0, then the marble would continue to travel forever trying to reach the same height that it was released from. Based on Galileo's concept, Newton gave 3 fundamental laws for the motion of objects. These 3 laws are together known as Newton's laws of motion. In today's class, we will study the first law of motion. The first law of motion states that an object remains in a state of rest or of uniform motion in a straight line unless compelled to change that state by an applied force. Let us take the example of a football that is at rest on the ground. Now this ball will continue in its state of rest until and unless a force is applied by kicking it to change its state from rest into motion. The first law of motion is also called law of inertia. Next, let us know why this first law of motion is also called law of inertia. Every object, when applied with a force, its first tendency is to resist that force. That is, the object will not be willing to change its present state. For example, suppose we are standing in a bus that is at rest and suddenly the bus begins to move, then we tend to fall backwards. Have you ever thought, children, why this happens? Yes, this is because the sudden start of the bus makes the bus move as well as our feet, which is in contact with the floor of the bus, will also move. But the rest of our body opposes this motion because of the tendency to resist this force. And this tendency is what we call inertia. Let us take another example of us sitting inside a moving car. When the brakes are applied, suddenly The car slows down, but our body opposes this force due to brakes because of our tendency to continue in the same state of motion. This tendency is what we call inertia, and the same tendency makes us fall forwards and get injured. That is why we use safety belts, which prevents us from accidents by exerting a force on our body to make the forward motion slower. From these two examples, we come to know that the tendency of undisturbed objects to stay at rest or to keep moving with the same velocity is called inertia. That is why we call the first law of motion as the law of inertia. We see a pile of similar carom coins made on the table. Using the striker, if a sharp and strong horizontal hit is given at the bottom of the pile, then the lowest coin moves out quickly and all the other coins fall vertically on the table. This is because of inertia. Here we see a 5 rupee coin set on a stiff card covering an empty glass tumbler standing on a table. If we give the card a fast and sharp horizontal flick with a finger, then the card shoots away and makes the coin fall vertically into the glass tumbler. This is due to inertia of the coin that tries to maintain its state of rest even when the card flies off. From these examples, we observe that an object that is at rest tends to remain at rest, and an object that is moving tends to continue its moving. This natural tendency is what we call inertia. Now the next question to think is the inertia of all the objects same? The answer is no. Let us take the example of an empty box and a box full of books. Which is easier to push? Obviously, the empty box, because its inertia is small and the force required to push is also small. This shows that heavier the objects, larger is their inertia. And how much inertia an object has depends on the mass of the object. Now, let us do some questions. Question 1. Which of the following has more inertia? Question A. A rubber ball and a stone of the same size. Question B. A bicycle and a train. Question C. A 5 rupee coin and a 1 rupee coin. Solution. Just now, we saw that greater the mass, larger is the inertia. In the case of question A, stone is heavier than the rubber ball, so stone has larger inertia. In question B, train is heavier than the bicycle, so train has more inertia. And in question C, a 5 rupee coin is heavier than the 1 rupee coin. So, the 5 rupee coin has more inertia. Question 2. In the following example, try to identify the number of times the velocity of the ball changes. A football player kicks a football to another player of his team who kicks the football towards the goal. The goalkeeper of the opposite team collects the football and kicks it towards a player of his own team. Also identify the agent supplying the force in each case. Solution. Here, the velocity of the ball changes 4 times. The first time, as the football player kicks the ball, its speed shifts from 0 to a certain value. So here the velocity gets changed. The agent here is the football player. The second time is when another player is kicking the ball to the goal post. The ball's direction as well as its speed changes. Here the agent is the other player. The third time is when the goalkeeper collects the ball and the ball comes to rest. Its velocity reduces from a certain value to zero. Here, the ball's speed has changed and the goalkeeper is the agent, who used a counter force to change the ball's speed. The fourth time is when the goalkeeper kicks the ball to pass on to his teammate, so the velocity of the ball changes from 0 to a certain value. And here the goalkeeper is the agent. Question 3. Explain why some of the leaves may get detached from a tree if we vigorously shake its branch. Solution. Here, before the shake, the leaves were at rest. During the shake, the leaves will have the tendency to continue in its state of rest. This is due to inertia of rest. The shake puts a stress on the junction of the branch and the leaves, and they fall off from the tree. Question 4. Why do you fall in the forward direction when a moving bus brakes to a stop and fall backwards when it accelerates from rest? Solution. When a brake is applied to a moving bus, the upper portion of our body, which was already in motion with the bus, tends to keep moving due to inertia of motion. That is why we fall forward. But when a bus gets started from rest, our body, which was already at rest, tends to be in rest due to inertia of rest. That is why we fall backwards. That's all for today. Thank you.